Hello viewers, welcome to the new video lecture. In this video lecture, we are going to discuss unsolved numericals. So we have 2 to 3 numericals which is unsolved, and in this lecture we are going to solve these numerical in detail version. So stay tuned. Line was shown to a magnetic bearing of 35 degree 15 minute in an old map when the declination was 13 degree 45 minute toward the east. To what bearing should it be set now if the present magnetic declination is 4 degree 15 minute toward the west? And here the answer. But now we are going to solve this numerical. First of all, we just write the given data, and this is the question number 11. So first of all, we just write what are our given data in this question. So in this question, it is saying the magnetic bearing. So this is our magnetic north and this is magnetic south. From this magnetic north, we just draw a line, and the angle taken from the magnetic meridian, which is 35 degree 15 minute. Let's name this line A and B. So this is the older situation which is provided by an old map. Okay, when this case is going on, there was a declination of 13 degree 45 minute toward the east. It means your true north will lies this. So this is the value of your true north, or you can say this is the value of your geographical north. Okay, so if you draw a north meridian to this side, then this magnetic meridian moves toward the west. Similarly, if you draw this true north in this direction, then your magnetic meridian toward the east. So in the both cases, we just take one case, and that is this the case number 2, because when we draw the true meridian in our second quadrant, then it will shows that the magnetic meridian will be in the north directions. So according to the question, we just apply the second one method, then we rub this one. So this angle, the angle is 13 degree 45 minute. Okay, so in this case, what is the true bearing of AB line? So true bearing of AB line will be, it is the angle taken from the true meridian, hence this will be equal to 13 degree 45 minute plus 35 degree 15 minute. On solving the true bearing of line AB, we find that the total angle is 48 degree 60 minute. Convert this 60 minute into degree, which will be equal to 49 degree. Now we draw another diagram which is shown in this figure. We draw our line AB with green color and our true north direction toward the upward direction. The angle from the true north or true meridian of line AB is 49 degree. We have drawn this. Now according to question, the question says that magnetic meridian or the magnetic declination is toward the west. So we draw this magnetic meridian line, magnetic north to magnetic south, the imaginary line, it is an imaginary line. So this line is lean toward the west, and the angle is given here 4 degree 15 minute. 4 degree 15 minute. Okay, now what is the magnetic bearing of this AB line? So the new magnetic bearing of AB line will be taken from the magnetic meridian, angle taken from the magnetic meridian, and it can clearly seen that this is the angle which is taken from the magnetic meridian. So the value of this angle is equal to 4 degree 15 minute, which is the value of magnetic declination, plus 49 degree, which is the value of true bearing. So in that case, this gives the answer 53 degree 15 minute. Okay, so we can say that 53 degree plus 15 degree divided by 60. Okay, now convert this 15 minute into degree concept. So this will be like this. So it will be 53 degree plus 1 by 4, which is equal to 1 by 4 is equal to 0.25 degree. On adding these two values, it will be equal to like this. So this is your final magnetic bearing of AB line. Now we check this with our given answer. So here the answer is in this form. So this dot will be removed. This will be 53 degree 15 minute, and if we convert this whole value into degree form, so this is the degree form concept. I hope you understand this numerical. If you have any doubt, then refer again to the video. Now we move to question number 12, which is the second numerical of our lecture. So the question number 12 say that the following bearings were observed on a closed traverse. Find the included angles and correct the bearings of the lines. Draw the sketch of the plot if AB is equal to 90 meter, BC equal to 90 meter and CD equal to 60 meter, and show in its all included angle. So this problem is related to your included angle and also related to your closed traverse. So these are the two points which we note during the question analysis, and you have to also find the correct bearings, and this bearing will be the true bearing and taken from the true meridian. We already covered these terms already. Now we move to the given data, and here is a table. This table contains three columns. The first column represents line, and here the line are AB, BC, CD, DE, E and A. So you can clearly see that the line starts from the A point and end at the A point. Hence this is the problem of closed traverse. The second column gives the value of forebearing, and the third column gives the value of back bearing. So how we solve this numerical? We just uh, work with the given data. First of all, given data, what we have given data, we have table, and we have some measurements of lines. There are three lines, AB, BC and CD. These are given in the form of meter. So this is our given data. Now what we have to find? We have to find uh, internal angle, internal angles and correct bearing. Okay, so first of all we draw a diagram related to our given table. Let's assume this is our north directions, so we are going to take every angle from this north directions in clockwise directions. So this is our north. From here we just draw our B point in the directions of 140 degree 45 minutes. From again this B point we draw our C point like this clockwise direction, and this angle is 216 degree 30 minute. Again this is our north directions, and again we are going to take angle up to the line CD, and this angle is at station C, which value is 209 degree 15 minute. The last one at the D station, which is the highest angle from the all data. So from this point we just draw up to here. No, we just draw up to this position, and this positions give the value of 60 degree 15 minute. So first of all we just draw a simply a figure according to given data, and these data are your calculated data. These data was calculated by compass, so these data having some error also, but we just ignore those error and just focus on internal angle. So now we are going to discuss how to calculate the internal angle. In that case we have I am interested to find this one angle. Okay, so this is my aim, to find this one angle. So if you see the figure, the large line which is taken from the north directions and end at the line AE. So you can say that this angle is forebearing of AE line, or you can say that this is the back bearing of EA line. Okay, so in that case you have to find the back bearing of EA line, and here you can see that back bearing of EA line is 240 degree 15 minutes. So if you are interested to find internal angle at A, so you just need to minus these two values from one to from this. Okay, so this is the first phenomena to find the internal angle. Similarly, at station B, if you draw this larger one like this, so this is the forebearing of line BA, or you can say that back bearing of line AB, and back bearing of line AB is given in your table. From this back bearing you just need to reduce 216 degree 30 minutes. So I just highlight this point here. So back bearing of AB line is this one. From this value you have to reduce 216. So if you reduce this value you will get the internal angle. Similarly, we move to the third point, and this is this C station a little bit change. In that case you just first of all you just need to calculate this one angle. Okay, so this one angle is clearly seen that if you minus 209 degree 15 minute from 360 degree, you will get this one angle. From that value, if you add this one angle, so this one angle, the small arrow is the forebearing of CB line. You can say that this is a back bearing of BC line, and BC line back bearing is given in table. From that value you just add these two values, the first one like this and second one like this. Okay, so let's solve these three stations. First of all we solve for these three stations, then we move to D and E station. So here is the calculation for internal angle A. Okay, we already said that it will be equal to the back bearing of EA line minus forebearing of AB line, which is 140 degree 45 minutes. On solving this we get this value. Similarly, for internal angle B, we already discussed that how we calculate this internal angle. We just use forebearing of BC line and back bearing of AB line. On solving this we get this one answer. After the C angle, we just say that first we are going to minus 209 degree 15 minute from 360, so we get the value of 150 degree 45 minute, and then add the back bearing of BC line, which is 38 degree. After solving this, we get 188 degree 45 minute. Now we move to the C point. In this case, you can see that if you minus 319 degree 45 minute with 360 degree, you will get this one angle. After that, if you add this one angle, okay, which is shown by the light sky blue color, so this small angle is the back bearing of CD line. According to the table, the back bearing of CD line is 30 degree 15 minute. So here the 30 degree 15 minute written here. So 360 degree minus the given angle, the fore bearing of TE line is 390 degree 45 minute. After solving this, we get 40 degree 15 minute plus 30 degree 15 minute, and our final answer is 70 degree 30 minute. Now we move to the E point. In the E case, this is the longer arrow. This longer arrow gives the value of back bearing of DE line. So back bearing of DE line is 139 degree 45 minutes. From this value we minus this green angle, which is 60 degree 15 minute. So on solving this, we get 79 degree 30 minutes. So this is the internal angle. Now we move to step second. And what is our step second? We just sum up this all internal angles. Okay, the sum up of all internal angle can be represented like this. Sigma internal angle will be equal to angle A plus angle B plus angle C plus angle D, and the last one is angle A. So according to this value, the summation of all angle will be equal. On addition of all angles, we get the value of 537 degree 180 minutes. Now we convert this 180 minutes into degree form. So this will be equal to 537 degree plus 3 degree, okay, because 1 degree is equal to 60 minutes, so 3 degree is equal to 180 minutes. In that case, this will be equal to 540 degree. Now we move to the formula of closed traverse. So according to closed traverse, the formula said sum of all internal angle for a closed traversing will be equal to 2n minus 4 multiply 90 degree. So in that case, this figure gives the pentagon shapes, okay, because here there are 5 sides, so n is equal to 5. 2 into 5 minus 4 multiply 90 degree gives the value of 10 minus 4 multiply 90 degree. So here we find that 6 into 90 degree, and this is equal to 540 degree. Okay, so this is the 540 degree, and here our summation of internal angle is 540 degree. So we can say that from step 2, the angle which is found from the bearing, calculated bearing, these internal angles are having correct value. Now we move to the next step, which is our correction for bearing. So now we are moving for step 3. For this step 3, we just draw a table and then we correct everything inside the table. So first of all, we draw a table like this. In this table we just add our internal angle also. So these are the value of internal angle A, B, C, D, E. Now we check that which bearing gives a correct difference of 180 degree. So according to this, here is the 45 minute, 15 minute not giving, 30 minute, 00 minute not giving. This is 9 degree 15 minute. Here is a 0 degree 15 minute. So this is not the complete difference of 180 degree. In the last case, you can see that line DE gives the complete difference of 180 degree. Okay, and again the same value EA line is also giving the complete difference of 180 degree. So in that case, the difference of forward bearing minus back bearing is 180 degree. So we can say that station D, E and A are free from local attraction. So all the reading which is taken from these stations are free from local attractions. When we move to the CD point, so at D point the back bearing reading is taken, hence we can say that 30 degree 15 minute is already free from local attractions. Now move to AB line. In that case we already say that our station A is free from local attractions, hence the forward bearing reading which is taken from station A is also free from local attraction. Okay, so now we have only 4 reading. To correct these 4 reading, we just move to our figure, and now we are correcting this BB. If our first reading is correct, okay, so this forward bearing of AB line is 140 degree 45 minute is less than 180 degree. Hence, according to formula, the back bearing is equal to forward bearing plus minus 180 degree. In case of AB line, this will be equal to plus. So hence we can say that back bearing of AB line is equal to forward bearing, which is 140 degree 45 minute plus 180 degree. So this gives the value of 320 degree 45 minutes. Okay, so this is the correct bearing. So you have two methods in this case. The first one, you have to find the corrections in this bearing, then that corrections add to the this value for bearing, or we have a second method which is applicable with the figure. So if we know the back bearing of AB line, the back bearing of AB line is like this. This is the longest one. This longest one is the back bearing, and the value of this back bearing we already calculate, which is 320 degree 45 minute. So from this longest value, if we minus our internal angle B, we will get this shorter one, and this shorter one is the angle taken from the north meridian towards the line BC. So we can say this is the forward bearing of BC line. Okay, so here is a simple phenomena. If we minus our internal angle B, and internal angle B is 101 degree 45 minutes, so we get our forward bearing, and this is equal to 19 degree 219 degrees. So this value will be changed to 219 degree. Okay, so if this value is correct, the same formula apply for back bearing, which is for equal to forward bearing plus minus 180 degree. In that case, 219 degree is greater than 180 degree. Hence, the back bearing is equal to forward bearing, which is 219 degree minus 180 degree. Okay, so this will be cancelled like this. So the final answer will be 9 and 3. So this is the back bearing of BC line, which is 39 degree. Okay, so now we have only one reading is here, which is the forward bearing of CD line, which we need to correct, otherwise all the readings are already corrected. Okay, so I just cut these values which is wrong, and we already find the correct value. So now move to CD. Now move to station C. Okay, we know the internal angle, we also find the back bearing. So back bearing of BC line is already 39 degree in the last calculation, and we have this internal angle also, this complete internal angle C angle inter C. If we minus our 39 degree from the internal angle, we will get this one value. Okay, and if we calculate this one value, so minus this green portion with 360, we will get. So if we minus this green portion with 360 degree, we will get this one value, and this is the forebearing of forebearing of CD line. So this is the our ultimate aim. First of all, we will get 360 minus 39 degree. So in that case, we just minus. So we are going to minus this 39 degree with internal angle C, which is our 88 degree 45 minute. So our answer will be 45 minute, and this gives the value of 188 minus 39, 149 degree 45 minute. Now minus this value with 360. So this will be equal to 210 degree 15 minute. Okay, so now we calculate the all the incorrect bearing. Okay, so we have already, this is correct value, this is correct value already, this one is correct, and this one also correct. We calculate this back bearing, which is equal to 320 degree 45 minutes. After calculating this, we go to the forebearing of BC line, which is 219 degree. Then solving this, we get the back bearing of BC line, which is 39 degree. Solving this 39 degree with internal angle, we get forebearing of CD line. And if we minus 180 from this forebearing, because 210 degree is greater than 180, so apply this formula for back bearing, we will get this one value. Okay, so here the check for this question number 12 is also say that our procedure, our calculation is correct. So in the last, you just need to draw this table in your fair copy. So question number 13 and question number 14 will be covered to the second part of video lectures. Thank you all for your precious time. Stay tuned.